everyone, Katrina here, and today I'm going to show you how to complete the square so that we can get from standard form all the way to vertex form. Today we will be looking at quadratic equations that have this form, ax squared plus bx plus c. When we're graphing quadratic equations, it's important that we learn how to find their roots, which you can find from my previous videos. However, it's also important to be able to find the vertex. That will help us determine what is the range of our function. It will show us what the vertex is, which is either our max value or min value, by looking at our d value here and our c value here. So our vertex has the form dc. Okay. Let's dive in so we can learn how to actually do this. The first thing that we want to do to complete the square is that we want to create a perfect square trinomial. Here's a link to my previous video which shows you how to factor a perfect square trinomial. In this case, when we're not given a perfect square trinomial, we want to complete the square to create our own perfect square trinomial. Let's look at an example to clear this up. Let's first consider a function x squared plus 4x plus 1. Let's first test to see if this is a perfect square trinomial. We do that by dividing our middle term by 2 and then squaring that value. This gives us 2 squared, which equals to 4, and this does not equal to 1. Therefore, we do not have a perfect square trinomial. So let's make one. What we have to do in this case is we have to put brackets around our first 2 terms. Okay, so now we're considering this section, x squared plus 4x in brackets, and then we're going to leave this one on the side for now. The next step is we now need to divide this middle term by 2. So we're going to take 4 divided by 2. We're then going to square this value, and then we need to add and subtract it to our equation. Let's take a look at what that gives us. So now we've got x squared plus 4x, okay, just like we had before. And now we're going to take this new value that we have, and we're going to add it and subtract it. By adding and subtracting it, that ensures that we are not changing the integrity of our original function. So what is 4 divided by 2 squared? So 4 divided by 2 is 2, and 2 squared is 4. So that means we're going to add 4, and we're going to subtract 4. Okay, so we're still considering this whole piece, and let's keep the 1 over there. Now what we're going to do is we're just going to look at our first 3 terms, x squared plus 4x plus 4. Okay, and now let's test to see if this piece over here is a perfect square trinomial. So again, we take 4 divided by 2 equals to 2, square that number, that equals to 4. And that equals to our c value, so we've got a perfect square trinomial. We know how to factor perfect square trinomials. For perfect square trinomials, we simply take our middle value and divide it by 2. So then we just have x plus 2, and then that whole piece is squared. So this piece over here, highlighted in yellow, this can be factored just like this. But now we can't forget about our remaining 2 pieces of our function. We still have minus 4 and plus 1. So in this case, we'll just add those together, so that gives us negative 3. And there you have it. It's in vertex form. So now let's analyze this to determine what is the vertex of our function. So like I said before, our vertex is the pair dc. In this case, this is positive, so that means we're going to have a negative d. If this was negative, we'd have a positive d. And we know that by looking at our original definition of vertex form. In our original definition, there's a negative here. So that means if we have a positive here, that's the same thing as having x minus negative 2 squared minus 3. So that's how we know that our d value is negative. Therefore, we have that our vertex here is negative 2 and negative 3. So let's look at another example when a does not equal to 1, so we can see how we can actually factor that. So here now when a is not equal to 1. Let's do an example. Let's consider negative 2x squared plus 8x minus 6 equals to 0. We can immediately see that this is not a perfect square trinomial. So let's follow our steps and take brackets for over our first two terms. We can see that a does not equal to 1. That means that we have to factor out this term in order to properly complete the square. So let's factor out that negative 2. That gives us with x squared minus 4x. And then we still remember to keep our constant out on this side. Okay, so now we're going to go through the process of dividing this term by 2, squaring it, adding it, and then subtracting it. So let's do that together. So we keep our x squared minus 4x. 4 divided by 2 equals to 2, and 2 squared equals to 4. So that means we're going to add 4 and subtract 4, and then we keep our negative 6 out here. Okay, so remember we only want to consider our first 3 terms to create our perfect square trinomial. So that means that we actually have to remove this negative 4 outside our bracket. But unlike that last time, we have a coefficient that's not equal to 1. So that means in order to remove this term, we have to multiply negative 4 by negative 2. So we have negative 4 times negative 2, which equals to 8. And we have to do that in order to remove it from our brackets. So now we end up, so we rewrite that negative 2 multiplied by x squared minus 4x plus 4. And then now we have this new 8 term, so plus 8, and then minus 6. Okay, so here we see that we have a perfect square trinomial, so we know how to factor that. So we simply just put it in the form x minus 4 over 2. And remember, this is a minus. This sign follows whatever sign that we have up here. So we have a negative here, so that means we're going to have a negative over here. 4 divided by 2 is just 2. We square this term, and then we have 8 minus 6, which equals to 2. And there you have it. This is in vertex form. So now let's grab our vertex. So we remember that this is our d value, and this is our c value. So therefore, our vertex here is 2 and 2. So this is another example how we can convert an equation that's in standard form into vertex form. And in this example, our leading coefficient was a value other than 1. So that means we had to do the extra step to factor it out of our equation before we can go into the steps of completing the square. So one last time, let's write out the steps for us, just so we can sink that into our head. So let's have x squared plus bx plus c. In order to put this into vertex form, we have to write this as x squared plus bx plus b over 2 squared minus b over 2 squared plus c. We're then going to look at this first part, which is a perfect square trinomial. That's going to be factored, and we end up with x plus b over 2 squared, and then we have a remaining piece, negative b over 2 squared plus c. And remember, whatever this term is has to match this term. So if it's a plus, then it's a plus. If it's a minus, then it's a minus. I hope this cleared up completing the square for you. And if you found this video interesting, please drop a like and don't be afraid to comment below any questions that you have, and I can make a new video showing even more examples. Please subscribe for more, and I will see you next time.